Hello! We're going to go over the projectile motion castle learning homework now. 15 questions, all multiple choice, similar to what we're going to see tomorrow. So, good, it looks like we can see that. I'll go through this quick. Projectile lands at the same height from which it was launched. Right, so it's just on a field and we're going up and we're coming back down. Which would result in the greatest horizontal displacement. So we know the optimal angle is 45 degrees. So we can cross out 2 and 4. And then we just need to think, is it going to go further away if we have less or more velocity? And choice 3. We want the optimal angle of 45 for your range and the maximum velocity. Question 2. A projectile with mass m is fired horizontally. All right, from a height h above the ground. So it's something like this. This is height h. Which change would have a greater time of flight of the projectile? So we know that mass has nothing to do with how long it takes something to fall, because acceleration in the y is always negative 9.81. We know if we started half our height, which is going to get there sooner because we don't have as much distance to travel. We know from the shot versus drop demo that your velocity in the x dimension doesn't matter. All that would happen is you would land twice as far away. So this one's going to be choice 4. If we start twice as high up, we're going to have more time to fall. Question 3. A soccer ball is kicked into the air with an initial speed of 20 meters per second and returns to level ground. Okay, so this one, kick in the air, comes back down. Which angle should the ball be kicked in order to travel the greatest horizontal distance? Here we go. Choice 3, 45 degrees. Easy. Simulations showing us that. Question 4. Which combination would result in the greatest horizontal range? All right. So to get the greatest horizontal range is where a projectile. We want a big x component. So we want Vx to be a big number because that means we're going fast as we travel. And we want Vy to be a big number because the more Vy we have, the more hang time we have. So we basically just want the most of everything. So that's going to be choice 4 because that has a 6 in it, that has a 6, that has a 6, and this one is just a combo of 8s. So that's what we want. Question 5, a rock thrown straight up into the air at the highest point in the rock's path, the magnitude of the net force. So whenever we throw anything in the air, even if it's straight up and then comes straight back down, if we were to look at the forces acting on it, it's just the force of gravity, which is equal to mg. And that's what free fall is, when you just have gravity acting on you. So it's going to be the same as the rock's weight, because that's what your force of gravity is. That's just your weight. Question 6. A projectile is launched at an angle above the ground. The horizontal component of the projectile Vx is 40. Okay. The vertical component of the velocity is 30 meters per second. So this is tricky. So it seems like we have to do calculations, but because it's multiple choice, we don't. Welcome to homeroom. So this is 40 to start, and this is 30 to start. So we know that anywhere along this path, Vx is always going to be 40. And that's because there's no acceleration in the x direction. So x doesn't change. So we can cross off 3 and 4. And we do know that it can't be 30 because this has to change. Maybe here it's 15, and then here it's 0. And then here we get negative 15 or so, and here we get negative 30. So we know our y, because of the acceleration in the y direction, is equal to negative 9.81 meters per second squared. As soon as it's launched, it's going to go 29, 28, 27, 0, negative 1, negative 2, negative 30. So we know it has to be choice 1 by process of elimination. Of course, you could calculate this, but that seems like a lot of extra work to do. What would you use? I think you'd use VF, solving for VF equals VI plus AT, and you would do this in the y dimension. So VF equals 30 plus negative 9.81 times 2. Oh, let's get some lights back in here. There we go. Alright, question 7. You have 4 projectiles. They're launched and returned to level ground. The data table below shows some numbers about them. So which object traveled the greatest horizontal distance? Alright, so we don't need the initial vertical speed. This is like the last step. VIT plus 1/2 AT squared. So we're only going to work in the x dimension. So we know our acceleration and everything goes to 0. So really you're just doing d equals VI times t for the horizontal speed, because this controls your time of flight. So you could use this to calculate the time of flight, but they already give it to you. So you will do like d equals 40 times 6. I'll do d equals 60 times 4. Again, we're just doing each combo. D equals 50 times 5. And d equals 80 times 4. So when you do this, I believe 80 times 4 gives you the biggest answer. But of course, you could check it with your calculator. 40 times 6, 240. 60 times 4, 240. Amazing. 50 times 5, 250. And 80 times 4, 320. There you go. So you travel furthest in choice D. Alright, question 8. This is a horizontal projectile problem. So you could use a chart. This is going to be the first half. I guess I'll make a chart. I love a chart. V, I, B, F, A, T. For 0, negative 50 is what we're going to fall. This is always 0. That's always negative 9.81. The 4 comes from here, and it says very specifically horizontal speed. Alright, so how much time is required? T equals VIT plus 1/2 AT squared. And we're only going to use the y dimension to find time. So negative 50 equals 0 times t plus 1/2 negative 9.81 times t squared. So t will eventually equal, once you do all your math, negative 50 times 2 divided by negative 9.81, square root of the answer, 3.1. So this is choice 1. Which body is in equilibrium? Ooh, equilibrium, a throwback question. Net force equals 0 Newton. That's what we're looking for equilibrium. I guess this was tricky, but it is choice 3 here. You may be confused about satellites because we haven't done those yet. A projectile at its highest point, you should know, still has your force of gravity. Free fall is the same as that. So a car moving with constant speed, because constant speed means A equals 0, which means net force equals 0. And I threw this one in here because we keep botching that, or we kept botching that on the last test. Question 10, a projectile is launched at 45 degrees, travels through the air, compared to its theoretical path with no air friction. The actual path is going to be less and less. So choice 1, you lose in every direction. So you lose in your y and you lose in your x when you have air resistance. 2 spheres, A and B. You already know where this one's going. Sphere A is shot horizontally with a speed of 40. Sphere B is shot horizontally with a speed of 20. Which statement describes the time required for each to hit the ground? It's going to be the same. You watched the video in real life. You saw the demo in real life. You understand that everything falls towards the earth at the same rate. So it's going to be 1, 2, or 3. Yeah, so it's choice 2. Sphere A lands twice as far away because sphere A has twice as much velocity. Same time, double the velocity, double the distance. Because of that equation. Question 12. A machine launches a tennis ball at an angle of 25 degrees above the horizontal at a speed of 14 meters per second. 25 degrees, 14 meters per second. The ball returns to level ground. Which combination of changes must produce an increase in time of flight? Time of flight. We want to go up more into the air then. So anything that's going to get me up into the air. Increase the launch angle and increase the speed. Yes, very good. So if I increase the launch angle and decrease the speed, I may not go as high. So this is all about just getting higher in the air to get more time of flight. More height, more time. Push that right. Alright, well, we got 3 left here. Question 13. It's fired from the ground with an initial velocity of 250 meters per second at an angle of 60. Okay, so 250 meters per second, 60 degrees. Why does the projectile have no acceleration in the horizontal direction? Oh, because there's no force. There's no horizontal gravity. Choice 2. There is no force acting on the object in the horizontal. You just have gravity pulling you straight down. Sweet. Question 14. You have it at A and then it's at B. Cool. I assume it's going this way. A to B. What happens to the object's acceleration? Ha! It remains the same. Biggest star, 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 star. This was the biggest missed question on the quiz from last week. Your acceleration, people, never change. It's printed on the reference table. Those are the 2 numbers I always tell you to put in the chart right away. It's just your acceleration due to gravity. Nothing in the x. And the last one, oh, this is going to get you. Which vector represents the acceleration? Acceleration, not velocity. Straight down because your force of gravity is straight down because your acceleration is straight down towards Earth. If your acceleration was sideways, I don't even want to draw it. It's choice 4. But if your acceleration was sideways, you would throw something into the air, it would continually go up, and it would get faster and faster to the side, which would be insane. I'd throw this pen in the air, and it would just fly away and hit the wall. That is not how it works. There's a review. Hopefully this video makes you happy. All right. Homework done.